Hey guys, congratulations. We are on the next unit for Math 8. So there's actually only 2 chapters left which that we're going to try and cover, which are surface area and volume. So before we can really get started on surface area and volume, we have to talk about how we look at objects. And in Math 8, we talk a lot about projected views. So there's 2 different types of views. There are pictorial views. And this is kind of like the picture that's down below here. It's literally a picture of the entire object, or a drawing that contains the entire object. Whereas a projected view shows a two-dimensional two-dimensional view of the object. And usually when we do a projected view, there are 3 types that we look at. We look at the top, the side, and the front. So if we look at the top, the side, and the front, why don't we look at the bottom, the other side, and the back? Well, when you're looking at an object, say this pizza box here, let me make it a little bit bigger. Looking at this pizza box here, the top and the bottom are the exact same. This side and this side are the same, and the front and the back are the same. So we don't need to draw 6 different sides, we only need to draw 3, and that will give us a representation that we're able to actually draw the object from the projected views. We usually would be doing this, I would give you the projected views and have you draw it. Unfortunately, it uses something called isometric paper, and due to the number of students who do not have access to a printer, I feel uncomfortable giving you guys that assignment when it's so hard for you to do without the proper equipment. I may put an assignment into the folder as a bonus, but you don't feel that you necessarily have to do it. It's just something that would be interesting for you to try. Okay, so for this pizza box, as you can see, I've actually made my notebook into graph paper, because when we do these images, we actually do it on graph paper. This allows us the most accurate possible drawings, just to make sure it is, well, as accurate as possible. So this pizza view, and we always label what view we're doing. So the top view, well, what does this look like? Well, pizza box is a square. And it's a rather large square compared to the sides. So that would be the top view. How about the front view? Well, the front view has to be as long as the top view, but it's not going to be as high because it's just a skinny little rectangle. And then the side, because it's a square, the side view is actually going to be the same as the front view, isn't it? If I was doing this on paper, I would be using a ruler. But unfortunately, using a ruler on my tablet just doesn't work very well. And the straight lines do not like to cooperate on the graph paper. Okay, so now, this one adds a bit more of a challenge. This triangular prism. So for the top view for this one, it's going to be, if you see one rectangle and then on the other side is another rectangle. So that's our one rectangle. But this, I wouldn't put a solid line for the top of this. I would actually put a dotted line because it's not broken there. It's just folded. And this kind of shows a peak. Okay, so what would the front look like? Well, the front looks like, oops, a triangle. And the side, if you look at the side, it's going to just look like that rectangle. And if you notice, I made sure that this is 4 because I made my initial one 4 high. So our cylinder or our cup. The top view for this one's kind of fun because if you look at the top of a glass, it's just a circle. If you look at the side of a glass or the front of a glass, it's basically a rectangle. And if you look at the side, it's actually going to be the exact same as the front. So the top view is our circle, our front view is a rectangle, and our side view is a rectangle. So these were pretty basic shapes. We have our rectangular prism, our triangular prism, and our cylinder. These are the shapes that we're going to be looking at going into surface area and volume. So for a bit of an added challenge, we have something called a composite object, which is made up of more than one shape. In class, we'd be building these with 1 centimeter cubes so that it's easier for you to see. If you do have something around the house that you can build it with, Lego or anything like that, sometimes that helps if you're struggling with seeing the views. If you don't, there's another way to do it. If you take a different color for each of the views, you can color it in. So if I'm doing the top view, I'm using this red, and I'm going to color the top of every square that I can see. So when I'm drawing the top view, I can see that it's 1, 2, 3 across in a straight line. And there's nothing in front of these two. And then it goes 1, 2. So this is why we draw it on graph paper, is because we usually have a lot of blocks that we're using for this to make it more accurate. Now let me use a brighter color. Let's do a yellow. So now if I'm doing the front view, I color in the front of every box. Okay. I can see that it's 3 across along the bottom with nothing over top of these two. And then it's 1, 2, 3 up the side. And now our last view, our side view, I'm going to color all the side squares, or all the sides of the squares. So I see, again, it's 1, 2, 3 across the bottom. And then on this side, it goes up 1, 2, 3. But on this middle one, it actually goes up 2. So if you look, it looks like stairs. Up 1, up another, up a third. So the side view will look like stairs, even though the front and the top look like L shapes. So today's assignment is only 5 questions long, and it's on page 42. And it's questions number 1, 2, 3, 6, 7, and 8. These are all going to be doing pictorial views or identifying the projected views, or using pictorial to do projected. If you have any questions, please let me know. I will be posting the next video for you guys on Monday, talking about nets, which is a kind of cool idea. Talk to you guys later.